Hello, this is Jose Cepeda and this is video quiz number 5 walkthrough. And in this circuit we were asked to calculate V sub 1 and V sub 2 from the circuit below. And this is the voltage across capacitors C sub 1 and C sub 2. And the way that I approached this circuit was to first identify that each circuit can be separated in loops, and that loop number 1, it goes across resistor of 40 ohms, and per voltage drop, the voltage across that loop, that resistor will be the voltage. And in this case, per voltage equals current times resistors, that'll give me a voltage of 40 ohms times the variable I, and that will be the resultant product of V sub 1. And then I combined a super mesh of loop number 1 and loop number 2, then went around collecting my terms, and per passive voltage convention, since the current was entering a positive terminal, therefore it would be 60, and then I started collecting all my other terms with the variable current around. Then by applying the Kirchhoff voltage law, and then I solve for that variable, which yield a current of 6/7 amps. And the next thing I did was substitute my unknown variable with my previous equation, V equals 40I, which yield a voltage of 34.29 volts. And then the next thing I did was to start applying KVL law around loop number 3, and per DC conditions we can consider the capacitor as an open circuit, and that's basically what I did. And by considering it as an open circuit, it also means that there is no current through the 50 ohm resistor, which in this case I ignore it during my collection of terms with the KVL law around loop 3. And so I started collecting my terms around it per passive voltage convention. It yielded a -60, then 20I plus the voltage across, and which is V sub 2. Since we already knew our variable current I of 6/7 amps, that current was plugged into our equation, then solve for V2, and yield a voltage of 42.86 volts. And that's how basically I was able to solve for the requested voltage. Thank you.